This video is a demonstration of the software developed in the EUBrazilOpenBio project for the use case titled Integration between Regional and Global Taxonomies, which cross-maps different taxonomic checklists and finds their relationships. The Crossmapper is a tool that allows taxonomists and data curators to compare two taxonomic checklists and find relationships between taxa in the checklists. Relationships include examples such as not found in, corresponds, includes, included by, overlaps, and so on. The demo shows how using the Species Discovery Service you can access taxonomic checklists for the family Apocynacea that come from two different data providers, namely the Catalogue of Life and Flora de Brazil. Once we have these two Darwin core archive files, one from each data provider, we can import them into the XMap web service, run the cross-map algorithm in order to find the relationships, save the results into the workspace, and finally examine them locally. So let's proceed then by opening a new web browser and going to the URL for the EUBrazilOpenBio Gateway portal. Once there, you log in with your username and password. Once logged in, you are inside the EUBrazilOpenBio virtual organization, which contains a virtual research environment. It also contains a laboratory which has the tools for running the two EUBrazilOpenBio use cases, the cross-mapping of taxonomic checklists and the ecological niche modeling. Inside the virtual research environment, we have at our disposal a set of tools that will allow us to run the experiment we want, just as in the same way you would do in a physical laboratory. For the demo, we are going to use the workspace, the species discovery services, and the cross-mapping tools. The workspace is basically a place where we can upload our data files. These files can be used by the applications to carry out calculations and save results. In addition, some applications can save new data files obtained from external sources. We can also share files between colleagues or download them onto our laptop for further study. You can create any type of folder structure that you want to best suit your needs. For this demo, I have created this structure in which I will save the DWCA files for the family Apocynacea, obtained using the Species Discovery Service in the folder checklist. I will save the results generated by the crossmap in the results folder. Now that we have the folders, we can get the DWCA files for the Apocynacea using the Species Discovery Service. In this case, we are not looking for an occurrence point, but rather a taxonomic checklist. In the field scientific name, introduce the name of the family. This tool allows us to seamlessly query different data providers in order to obtain the information that we are looking for, without worrying about the internal structure of each data provider or how to query them. Here, we are looking at which data provider contains information about the family Apocynacea. For the moment, we can see the Flora do Brazil, and shortly it should also appear in the Catalogue of Life. Here it is. To obtain the DWCA file from the Flora do Brazil, select its row by clicking on its checkbox and then click on the button View Details. A new window will appear with information about the family. If we click on the button Save Taxonomy Items, we only save the information for this specific taxa, but what we want to obtain is the DWCA file with all the taxa below it. To do so, scroll down and click on Family. This will open a new tab in which we can see all the genus that belong to this family. It's here by clicking the button Save Taxonomy Children where we can obtain the DWCA and all the taxa in this family that is in this data provider. When we click here, the system will start a new job that will run in the background and will request the data provider to obtain all the information it needs to create the DWCA. We can see the progress of the job by clicking in the Species Jobs, the button on the left-hand corner of the screen. It will open a new window where we can see the status of all the jobs that have been launched. Now let's do the same for the other data provider, the Catalogue of Life. Unselect the row of Flora do Brazil and select the row for the Catalogue of Life. Then click on View Details, go to the Family, New tab, and click Save Taxonomy Children. A new job has started, and if we go back to the window to see the progress of the species jobs, we can see that the 2 jobs have just launched and are still in execution. We can wait till they finish. This will take only a couple of minutes, but to make this video shorter, I'm using the files that I've already obtained previously to this demo, coming from the Brazilian flora and the catalogue of life. In this screen, we can also see the details of a job that is in progress by selecting it and clicking on the Info button. We can see all the genus that have been already obtained, and those ongoing, and those which are still pending. First, however, let's get the files and save them into the workspace. First, select the row for the FDB and click Save. I'm going to save it inside the folder called Checklist, and with the name Family Apocynacea from FDB. I then click Save. Let's do the same for one coming from the catalogue of life. Select the job and click Save. Select the folder, set the name of the file, and click Save. Now, if we go back to the workspace, we can see that in the Checklists folder, we have the 2 DWCA files, which we are going to use for doing the cross-mapping. Let's now go to the cross-mapping application. Here, we can see on the left-hand side of the screen some checklists that I've already imported, the cross map I've already run, and the results that I've already exported. Now, let's start a new experiment. First of all, import the checklists that we obtained using the species discovery services that we saved in the workspace. In the toolbar of the panel, you'll see Available Checklist. Click on the button Import Checklist, and let's first import the checklist for the family Apocynacea from the FDB. Set the name, in this case Apocynacea FDB, and select the file from the workspace, and finally click Import. We can see that the import is in progress. Once it finishes, we can inspect the content of the checklist that is now in the CrossMap database, from which we have already done some pre-processing to help the execution of future cross maps. We do the same for the import coming from the catalogue of life. Set the name, select the DWCA in the catalogue of life workspace, and click Import. We can see that a new asynchronous task has started and the importation is in progress. And now it has already finished. Once we have the 2 checklists imported successfully onto our system, we can run the cross-map. To do that, go to Crossmap, and there we click on Start Crossmap. In this experiment, we are going to compare the family Apocynacea coming from FDB against the family Apocynacea coming from the catalogue of life. Let's set a name and a description for the experiment. At this point, it's important to point out that the cross-map is directional. In other words, we are trying to find out the relationships between the taxa in the left-hand checklist against the taxa in the right-hand checklist. As a result of that, we will obtain, for example, the taxa which is present in the left-hand checklist, but not in the right-hand checklist. If we would like to see which taxa is present in the right-hand checklist that isn't in the left-hand checklist, then we will need to run another experiment inverting the position of the checklists. For this experiment, I'm going to use the checklist for the family Apocynacea coming from the Flora do Brasil as the left-hand checklist, and the one from the catalogue of life as the right-hand checklist. As I mentioned at the beginning of this demo, the cross-mapper allows us to find the relationships between the taxa belonging to the different checklists. However, in order to discover these relationships between the taxa, we are using the different scientific names, accepted and synonyms, and try to match them with other scientific names in the checklists. Once the matching has been done, the system will use them to infer the existent relationships between the pair of taxa. How this matching of names is done will depend on the parameters we indicate to the cross-map. For example, if we select the strict matching, we indicate that we are trying to match the complete scientific name that is compound with the binomial and the authority. If we don't choose strict matching, we will compare the names only using the binomial. If we select strict matching, we can also indicate a value for how to identify extra relationships between the taxa, and for those taxa that were not found, a relationship using the full name. In this case, we can select None, where we indicate that we don't want to identify these other potential relationships. By using names only for all the taxa that weren't found using the binomial and authority, we can find if they have some matching when we are only using the binomial. Finally, the option Generic Transfer. For this demo, I'm going to run the experiment using strict matching with the option Generic Transfer. First, you click Run. We can see that a new asynchronous operation has started and the XMap is in progress at the moment. And now it is finished. Once it is finished, we can inspect the results, seeing the relationships found between the taxa of both checklists. We can see some of the unfound relationships, and if we scroll down, we can see some correspondence. So this taxon in this checklist corresponds with the taxa in the other checklist. At this stage, we can export the results to the workspace in order to share them with a colleague or simply to evaluate them in more detail in our machine. So let's export them. The system will then ask us if we want to add the accepted taxa in the CSV files and the taxon ID. Let's click Yes. This will start a new asynchronous task which will create a zip file with 3 CSV files that we will see later. The job is already complete, as we can see here. Once it's complete, we can save this file into our workspace. So let's save it. I'm going to save my results in a folder as a zip file. If we now go back to the workspace, we can see that under the folder Results, we have a new file which contains the results of the cross-mapping. We can then send it to a colleague and see if he or she agrees with the results. In this case, I'm going to download the results on my laptop. Let's save it, for example, directly onto my desktop folder. As I mentioned earlier, the zip file contains 3 CSV files. The first contains the same information that we saw in the tabular data, showing the relationships between the taxa in one checklist and the other. The second file contains all the scientific names for all the taxa in the left-hand checklist, and all the scientific names of the taxa in the right-hand checklist that the cross-map has found some kind of relationship with. Finally, in the third file, we have all the taxa that were in the left-hand checklist but haven't been found in the right-hand checklist. This is the addit taxa file. All this information will go through the piping tool to send back to a set of experts to decide what to do with the taxonomic information and whether or not it should be included on the right-hand checklist. That's the end of the demo. Thank you very much.